Good morning, good afternoon, good evening, everyone, wherever you are, and welcome to the team project presentation of the very first multi-site interconnected space studies program, co-hosted by the International Space University and the University of Granada. My name is Göktuğ Karacaloğlu. I am the program director of the SSP, and it is my great pleasure today to be the master of ceremony for this prestigious event and address you from the SSP Mission Operations Center, located at the University of Granada in Granada, Spain. As many of you, I believe, followed, we had started this program 6 weeks ago, where our 34 participants representing 20 countries had been virtually allocated to their 3 space habitats on Earth, on the Moon, and on Mars. During the 6 weeks journey, they were tasked to work on a single team project, which required them to explore how high-speed intercontinental passenger and cargo transportation will become mainstream in the near future. And what a timely project it was, as we have all witnessed two historical events happened during the period of the TP directly connected to its topic. The first was Virgin Galactic's first commercial suborbital flight with Spaceship Two. And the second was Blue Origin bringing the oldest and the youngest persons ever to space on their suborbital rocket, New Shepard. It is always a challenge, but also an amazing learning opportunity to work with diverse and international teams where you have language barriers, different cultural norms, and people with different levels of expertise. As part of such a team, it is your responsibility to hear the voice of each individual and learn together. But in this year's program, the challenge was much greater than that, since each of our participants was only virtually connected to the rest of the team. And if that was not enough, they all have been operating on different time zones, some of them being 15 hours apart from each other. That is, for the last 6 weeks, ladies and gentlemen, some of our participants have been starting their days as early as 1 a.m. local time in the middle of the night. In such a challenging context, I'm extremely proud that our 34 participants have done a tremendous job and produced a very high quality report and an executive summary to discuss intercontinental suborbital commercial liners. In the meantime, here at the SSP Mission Operations Center, we have tried our best to support them with many supplementary activities, including daily seminars, interactive workshops, and obviously project-specific activities. And today, on their very last day of SSP21, we will be tuning in and listening to our participants as they walk us through the summary of their analysis and findings and recommendations. Maybe a quick note here on what to expect. As part of the SSP curriculum, we many times emphasize the importance of storytelling and public outreach to get your message across. So this is what the teams has been trying. In that regard, we also have asked our participants to demonstrate this learning as part of their final team project presentation. And this is why what we will watch today will not be a half an hour PowerPoint presentation, but rather a more interactive session where our habitat teams will use the power of media technology available to them. I would like to take this opportunity to acknowledge and thank the 2 co-chairs of this team project, Dr. Liang Cheng and Dr. Jan Walter Schroeder, who has led this project from beginning to end. And also the project assistant, Shirok Nambiar, and all the other teaching associates and experts who have made incredibly valuable contributions to the project work. So on my screen, I can already see the presentation team as well as the project chairs excitedly waiting for me to pass the floor on to them, which I will do in a minute. But before that, I would like to also acknowledge our sponsor of this team project. The team project has been sponsored by Beijing Interstellar Glory Space Technology Corporation Ltd. Without their generous support, none of this work and collaboration would have been possible. I would also like to extend my thanks and appreciation to our distinguished guests who are with us at the moment following this presentation and will be challenging our participants with their questions at the end. With that, ladies and gentlemen, I would like to now pass the floor to our esteemed project chairs, Dr. Chang and Dr. Schroeder, to walk us through their 6 weeks journey. And I think Liang will take over at this point. So Liang, the floor is yours.
Thank you. Ladies and gentlemen, welcome on board. This is co-chair Liang Chen speaking. Before our presentation, I'm honored to introduce our TP and Astro Express team to you on behalf of co-chair Jan-Walter Schroeder and the teaching assistant Prof. Nambia. The destination of our team project is to investigate the challenge, different options, and opportunities that suborbital transportation brings to humanity. Two significant crewed suborbital flights take off just before us, one by Virgin Galactic and the other one by Blue Origin. The Astra Express team had overcome the constraints of compact agenda, online environment, and time difference. Now they will provide some impressive recommendations for the future development of suborbital transportation. Wish you a safe journey on the suborbital liner of Astro Express. Sit back, relax, and enjoy the show. Now I'll hand over to participants. Thank you.
Welcome to the Plutosian Suborbital History Museum. As you prepare for your journey to Earth, we're excited to share the history of Earth's role in developing suborbital flight. Earthlings are a peculiar bunch, as you'll see. They eat strange food and breathe without thinking about it. Unlike most species, they are useless until age 20, and even then, it's questionable. And once they stopped referring to our home as a planet, peculiar indeed. But they did, surprisingly, miraculously, invent suborbital flight. I warn you that not all of this history is rosy, but it is nonetheless important. So, happy travels. Please keep your limbs attached and your consciousness in your head for the duration of this journey. Sit back and enjoy this history. And so long, and thanks for all the fish.
Thank you for that introduction, Alien Uli. What you're about to see is a prospective documentary-style presentation from what we imagine the future of commercial suborbital flight to be. You will be watching 3 scenarios set in the near, middle, and far future, which will demonstrate the considerations of our report and how these may be taken on by later generations. Hello everyone. Thank you for joining us to celebrate the 2200 New Year. Join us as we take a look at our history and celebrate how far we've come from that very strange 2021 when humans were so excited about their 5 minutes in space. Could you imagine how life was without suborbital flights 180 years ago? It took roughly 15 hours to go from San Francisco to New Delhi in an airplane. For now, let us imagine ourselves living during that time and hear an interview from 2021 with an expert of suborbital matters explaining about the challenges the people of that time were facing, just a month after July 2021, where the historic first commercial suborbital flights took place.
Hello everyone and welcome to our weekly Tech Talk. I am here today with my dear co-host Stella.
Hello everyone, hello Raul. We have a great guest today.
Yes, and indeed, with us today we have two well-known experts on matter of suborbital flights, Sarah and Hazel. It is a pleasure to have you here with us on this beautiful August day.
Great! So only selected humans have been to space and only a few were known professional astronauts. But this changed last month with the first suborbital flights of Virgin Galactic and Blue Origin. Do you think we will soon travel from San Francisco to Delhi in a few hours?
Well, thanks for having us on the show. The last month has been extremely exciting and has demonstrated the capabilities of humankind. These companies have started a new era for space tourism.
To answer your question though, for longer suborbital intercontinental flights such as the ones you mentioned, we're still facing many challenges. My best guess will be that we should not expect suborbital liners to replace airplanes anytime before the next decade.
So, could you please walk us and the audience through the challenges you just mentioned?
Well, to start with, currently there are not enough data regarding the effects of suborbital flights on the human body. Until now, only people in excellent health were allowed to fly into space. So when we consider the wider demographic of the future space traveler, we need to invest in more research to understand what the effects of frequent flights on a suborbital liner may be on human bodies in any physical condition.
Adding to what my colleague just said, so far everyone had to undergo extensive medical checkups and training, ranging from a couple of days to months before taking a flight.
I understand, so the long training duration is in contrast to the idea of having a short trip from one country to another. In this case, what would you suggest we should do?
I would suggest to introduce the concept of a suborbital passport. This passport would include important information such as your medical history, your training status, cumulative radiation dose, flight histories, and so on.
Oh wow, this sounds very exciting. I could also imagine that the passport could include additional information such as a distance tracker or your environmental carbon footprint.
That's a very good point, yes.
Talking about emissions, which environmental effects could suborbital flights have in the long run?
That is a good question, Stella. Some research suggests that emissions from suborbital flights affect the composition of the upper layers of the atmosphere. However, to be honest, we don't yet know how impactful these emissions will be once the flights become more widespread. The long-term goal is to use sustainable, non-toxic propellant to limit emissions.
That's great. What would this vehicle look like?
Launch providers will likely use a two-stage transport vehicle, at least in the beginning. The vehicle will have a rocket engine to provide sufficient power and velocity to propel it into a parabolic arc over the Earth. The exact trajectory and apogee will vary depending on the mission, and customers might require a trip specifically to reach altitudes above the Kármán line.
Did you say above the Kármán line? That will be above 100 kilometers. That is actually very high. Will communication even work at this altitude?
That is a challenge we will face with our current communication infrastructure. There are still a lot of challenges to make existing satellite communication systems for air and spacecraft reliable for suborbital liners. For example, high latency is a problem for geostationary satellites, and while constellations in low Earth orbit can provide lower latency, they're still in development. It is not an easy problem at such velocity and acceleration.
So you're basically saying that I might not receive any cell calls up there? But does that also apply to navigation?
Yes, communication and navigation services are a challenge there. So, for example, the pilot may have difficulties communicating with ground station in case of an emergency, or to accurately determine the current location of the vehicle. This is why it's so important to rely on satellite communication and navigation systems, as they provide global services and coverage in most cases all over the world. All the operations and safety procedures are still to be determined for the intercontinental suborbital flights.
Sorry everyone, it seems we are experiencing some technical issues.
Back to your cell phone question, you might have access to connectivity on board with high-speed communication, but priority will be given towards the communication and navigation for safety reasons.
Speaking of safety, who will actually take liability in case of, let's say, a passenger gets injured during the flight or the vehicle is damaged by a space object? Sarah.
Unfortunately, there are no international rules specific to suborbital flights yet. If the damage happens in airspace or on the surface of the Earth, you don't need to prove fault. The launching state of the space object will have to pay for damages. If the damage happens in outer space, you need to demonstrate that the damage was caused due to fault. The problem here is that the boundary of outer space is not clearly defined, so we don't know with certainty whether air or space law would apply to these activities, especially relating to liability for damage.
So I understood that the legal boundaries of outer space must be defined before we create and we can operate a suborbital liner. What are your recommendations where to start?
We need to define the legal boundary of outer space to be able to know whether air or space law would apply. Law is an enabler, and we need to be able to rely on these laws, whatever they are, to enable these activities to take place safely. A country is responsible for the activities of their nationals in space, which means they need to authorize and supervise their activities, and if there are damages to a third party, they are internationally liable. Insurance will be key as well.
Now we have talked a lot about the technical aspects. Leaving those aside, I would like to ask about your honest opinion, Hazel. Do you think that introducing the suborbital liner will allow access to space to everyone?
I absolutely hope so. In my opinion, everyone should be able to experience the overview effect. But this may take a long time since the development and manufacturing of hardware and infrastructure require large capital investments. As of now, we are still in the pioneer stage, and we have work to do before we're in the mass transportation stage. High initial fixed costs will be reflected in the ticket prices, and for now, they will be much higher than the average person can afford.
What can be done to reduce ticket prices so an average person will be able to buy one in the future?
I personally believe that the government should provide additional funding and help attract more investors for suborbital flights. More availability of flights will help bring ticket prices down, just like in the aviation industry. Once companies have recouped development costs and optimized production for these suborbital vehicles, costs will fall further.
Thank you very much, dear guests, for your insights. So, I always enjoy space sector's interviews. So let us now continue with the SpaceX Starship. When do you think we will see its first crewed flight?
Oh, SpaceX. I am also curious about when Elon Musk...
We are back, celebrating the new year of 2200, and our next segment is a retrospective on the year 2036, when Earthlings seemingly figured out point-to-point suborbital travel. However, as you will see, suborbital travel experienced some growing pains during this period.
My name is Captain Erica Jones. I recorded this message with my co-pilot, Arthur C. Smith, for future ISU SSP participants to share our cautionary tale. Humanity needs innovative and disruptive technology, but that tech also needs to be safe, reliable, and inclusive if we want it to be widely adopted and sustainable. Back in 2036, we hadn't worked out all the issues, like environmental impacts, air and space traffic management, nor did we have the transnational regulation.
On July 20, 2036, Captain John and I were set to pilot our 10th orbital flight. Together, this time from Sydney to London. What was supposed to be a 95-minute trip, inclusive of takeoff and landing, ended up as one of the longest days of my life.
For many of you are using the latest iteration of the digital suborbital passport. This was mine, version 15.2. We were still beta testing the concept in the 20s and the 30s, reconciling user privacy issues and data to drive design innovation. And as you can see, my medical data, radiation exposure, and flight history was recorded and tracked. With everyday humans traveling to space, the widespread use of human performance data was considered controversial.
That fateful day, as we approached the spaceport entrance, I was greeted by a demonstrator protesting against pollution and noise caused by the suborbital flight. They also felt the high price ticket exclude a majority of population. As companies tried to commercialize suborbital travel, we saw a trend in wealthy states building spaceports. Many felt marginalized.
As we continued to the gate, I couldn't help think about the protesters, because I understood their perspective. They didn't see the benefits of suborbital travel outweighing the perceived risks and negatives. Our industry certainly could have been much more engaging with stakeholders to get their buy-in. We could have generated a unified plan to lower prices and prevent rocket emissions. Commercial suborbital liners could become as routine as commercial airlines. We just weren't there yet. And yet, when I reached the gate, I got a dose of the protesters' reality. I saw my passengers fresh out of their pre-flight training. And I had confidence in the crew and the medical team who conducted that training. The passengers were not anxious in the least. In fact, quite the contrary. They demanded some champagne and they were, negotiating with the ground crew over their luggage. I silently nodded my solidarity to the crew as they reasoned with the passengers about mask constraints for such flights. After inspecting the thermal protection outside of the vehicle, Arthur and I were ready to go through the flight check paperwork. We started to go through the checklist and we tried to tune out the surrounding commotion. But the passengers just kept escalating their complaints. Everything from how the flight suits were heavy because of the equipment, like the dosimeter, or they were baggy and not designer enough. Despite all that training, they didn't understand that the main purpose of the suit is to ensure that their flight would be as comfortable as possible. Arthur and I go way back, like our last 10 flights. He's always calm under pressure, but today I could tell he was affected by the scene.
I remember thinking, they have bespoke suit? Do we need to remind them about how just a few years ago we had only one size for male and one size for female? I felt very bad for our crew. Everything they said just was not good enough for the passengers.
We entered the cockpit for final inspections before takeoff. We closed out the roll call with the flight ops team, including checks to ensure that the life support systems like air composition and pressurization is optimal. They reported that all systems are a go. See, by the late 2030s, suborbital liners made structural, thermal, and even material engineering advancements. And our vehicle was designed for reusability. It had already undergone 6 flights, and this one was lucky number 7. I had every faith in the vehicle because of that. Maintainability, inspectability, that was all a part of the design. Much of the flight would be autonomous. With everything looking nominal, soon we'd be ready for takeoff.
Right. I plug in the trajectory flight path. We will rely on our highly adaptable navigation and control system that directly interact with the other suborbital vehicle and sometimes worse with the space debris nearby. At that time, the flight basically started with a propulsion phase with a workout type of engine, followed with a suborbital flight over the Earth in microgravity condition, and finally a gliding re-entry to the spaceport. Air Traffic Control Center on the ground will monitor our flight and ensure that we have clearance for landing.
22 minutes into the flight, our navigation system alarm startled us. I couldn't believe what I was seeing. We were veering completely out of the trajectory flight path, and the risk of colliding with space debris increased with every second. And this debris could have been an obsolete satellite remnant from several decades ago, as identified by the Space Traffic Control Center. As designed, our navigation system automatically diverted the vehicle's trajectory, and I knew that our 10 passengers were going to panic if they realized what was going on. But of course, their in-flight infotainment screens had been moved to accommodate for their luggage lockers.
Right. If the passengers panicked, our two crew members on board would have revolt on their hand. Ray, one of our flight crew, notified us that some of the passengers experiencing motion sickness were getting worse, while others were getting agitated because of the vibration in general.
Vibrations and motion sickness are not uncommon in suborbital flights, but the trajectory change probably made it worse. I made a mental note of the flight manifest and started thinking through the passengers' digital suborbital passports and double-checked the biosensors. Were any of our travelers, were they prone to SMS-based motion sickness? Were any of them experiencing gastrointestinal discomfort, or did they have heart issues? And what if they had a history of psychomotor agitation that could endanger a fellow passenger? I had to disable the systems and pilot the vehicle. I notified the authorities at the ATC and STC that we would have to make an emergency landing so that they could be ready with the crews. Best case, I could divert us to the Saharan spaceport, or less ideal, someplace in the desert to minimize civilian casualties.
Finally, the ATC cleared us for a safe landing away from other air and spacecraft to make an emergency landing at the spaceport just outside of Laayoune. However, we couldn't make it and land closer to Dakhla, the westernmost part of the Sahara Desert. During the emergency landing, the Space Rescue Coordination Center tracked our final destination because satellite relayed our distress call. Depending on how and where we land, we couldn't rely on the local emergency support. We knew that the rescue team would get to us soon.
We survived. All 10 passengers, 2 crew, Arthur, and me. We landed safely. The rescue team was dispatched, and the ground ops team could deal with the vehicle. But unfortunately, the fallout for our liner was just beginning, because our VIP passengers were not happy with the desert tour. You know, back in the 20s, there was a very popular show called Black Mirror, portrayed near-future dystopias as commentary on social issues and the use of technology. Now, I hadn't thought of that show in decades, but surrounded by the irony of the desert, looking up to the sky from which we had descended, and as the crew tried to appease and reason with our disoriented and vexed passengers, for one brief moment I experienced deja vu, and I wondered if we were in a Black Mirror episode. As I said at the beginning, I hope this serves as a cautionary tale for you. As you know, suborbital travel became more widely adopted and routine, but even in 2036, we still had a ways to go. As you complete your SSP studies and develop orbital and deep space travel, I hope you are deliberate and conscientious about the benefits as well as the risks.
Well, Captain Jones and First Officer Smith's story is one that children learned about in school. Fast forward to 2050, and we can mark the sea change in suborbital travel history, when Earthlings solved many of the issues from early suborbital flight. Our next segment highlights that historic moment at the ISU Alumni Conference 2050.
Welcome, everyone. My name is Model 3 of 9. I am a robot AI. Thank you for joining us at ISU Alumni Conference 2050, the Lunar Edition. We're very excited to hold the first ever ISU conference at the Cernan Moon Base. My special guests are Adriana Barros and Oko Belkenchen, formed Astra Express, which has been called the most successful suborbital point-to-point company on Earth. Adriana is an award-winning young entrepreneur from São Paulo, Brazil. She is the founder and CEO of Astra Express. She has a master's degree in engineering and is a graduate from the International Space University. Oko Bekenstein is the Chief Technology Officer of Astra Express and also a graduate from the International Space University. Their company, Astra Express, has transported numerous humans, and today we are excited to share with them the news. So, before we talk about your exciting news, can you tell us what inspired you to start Astra Express? Tell us the founding story.
Thank you so much, Model 3 of 9. I'm so happy to be here. So to tell about something about myself, after I completed my master's degree, I studied at the International Space University, where I began developing this technology. Our team project was an intercontinental suborbital liner, and while we were researching, we came across this report from way back in 2021, and it helped us to build our company. In fact, we named our company Astra Express after the team who created this report.
Yes, so this report was our North Star in the early days of starting our company. One of the recommendations in this 2021 research report was cleaner, non-toxic propellant, and that's where we started.
Yeah, and this recommendation in the report was meaningful to me because as a child, my family and I lived near the airport that then later became a spaceport where there is a lot of noises and pollution. So I always dreamed of developing a cleaner and quieter solution so that the community like ours was not exposed to emissions and noise. While at ISU, I met Oko, who is a chemical engineer, and he had an idea for a greener propellant that created less pollution.
And to add on to Adriana's point, we decided to build a fleet of environmental friendly suborbital liners with a high level exhaust speed, ultimately with the goal of creating zero emissions in the near future. Our new fleet can carry passengers and offer stunning views from a high altitude. The original report mentioned cargo in the policy and law section, and we decided to start our business with transporting cargo as a model. And a few years later, we began transporting passengers. So we believe that if we could get the cost low enough to make ticket prices affordable, then we could expand and compete with airlines for the business class market. We could compete by delivering faster travel times with an exceptional experience.
I am impressed. Do you have agreements to be able to land in countries that weren't the destination country?
So this is a tricky question, but to answer, companies cannot enter into agreements with states, but the right of rescue is a humanitarian right that allows us to do emergency landing in such circumstances, and we also have international law instruments that further guarantee the safe return of passengers and vehicle to the launching state. The state we decided to incorporate our company really supports our activities and have helped providing a super clear legal and regulatory framework and to enter into all necessary international agreements for legal certainty and safety of both our customers and passengers.
I already feel safe now. Can you tell us about communication and navigation systems?
That's actually a very good question you brought up there. So one of the main challenge in this type of flight is the navigation of flight during re-entry to the atmosphere. Due to the high energy nature of the flow and wide range of Mach numbers to be covered, most of the standard navigation sensor systems cannot be implemented for use in re-entry vehicles. So we leverage on existing state-of-the-art sensors, such as sun sensor, which uses the position of the sun as a reference point, and ensuring these sensors are placed correctly on the vehicle. This addition guarantees a fail-safe navigation system during re-entry and thus ensures a smooth and safe flight. So regarding communications, the recent advances of the LEO, MEO, and GEO constellations enables a very low latency communication signal and a very wide and global covering field of view of the satellites, which works perfectly with our suborbital flight, which is a global service. And let's just say they travel at very high speed through regions which usually does not benefit much from terrestrial communications.
Amazing. Now it's the moment we've been waiting for. Can you share with us the news?
Yes, so since the navigation and controls recommended in the ISU report were very reliable and safe, we now have developed a totally autonomous suborbital liner. So yeah, that's the news.
Oh, now I am concerned. Will this put pilots' jobs out of the market?
No, not at all. In fact, we employ a team of pilots at Extra Express who have been training our artificial intelligence to operate the highest safety standards to continue the trusted relationships we have built with the customers.
Excellent. What exciting news. To repeat for the audience, this is the first fully autonomous suborbital vehicle, another first for the world developed at Astra Express. You've done so much work to innovate. Tell us more of the biggest challenges you had building this company.
Reducing costs. Yeah, this was the most difficult thing to do, but also the most important. Our vision is to make space accessible to everyone. Imagine what our world would look like if so many humans experience this overview effect. Our company values accessibility and sustainability.
And sometimes access to all and environmental sustainability are at odds with each other. But we feel that with our non-toxic propellant and rocket engine innovations, we are actually lowering the emissions created when we take people to space. And in fact, many of them return transformed and become more engaged in environmental initiatives here on Earth.
Yeah, and to give an example of this, one of our customers was flying from New York to India to welcome a new family member, and when they returned, they started a non-profit educational center that teaches kids about relationship between Earth and space. So this was a phenomenal moment for us.
Accessibility and sustainability are very important. What's the future you envision? What's next for Astra Express?
So we have helped many people connect with their families much faster than ever in history. We have transported thousands of doctors for timely life-saving medical emergencies, and we have flown hundreds of first response teams to disaster sites. We are proud that our company has provided positive impact in meaningful ways.
Yeah, and to add to Oko's statement, in the next 10 years, we have our eyes set on research for suborbital on the lunar surface. So now our wish is that by making suborbital travel more accessible to everyone, especially youth, and those who are new in their careers, we are creating this talent who will innovate the suborbital industry for the future. Towards this, we are supporting 5 scholarships for International Space University students the next year. So yes, be ready to grab this opportunity.
Yay! Very interesting. Well, that's all the time we have, unfortunately. I want to give you a special thank you to ISU alumni Adriana and Oko for joining us today and for sharing your exciting news. Please enjoy the rest of the conference. Goodbye.
We live in an exciting time for suborbital transportation, especially with Blue Origin and Virgin Galactic going up very recently. We have made great progress, however, there are still some gaps. Gaps in all aspects that would be required to scale suborbital transportation to commercial use, especially when we look at it from a holistic experience perspective.
The real potential of suborbital transportation as a commercial industry will only be realized by expanding the market and developing the technology and science to incorporate a new set of users for this system. Our team is deeply inspired by a future where seeing the Earth from space isn't limited to astronauts only, but is accessible to all.
We hope that the future scenarios we presented highlight some of the challenges and opportunities towards this future. It was important to consider multiple futures because we are certain there will be some unexpected twists and turns in the trajectory of commercial suborbital transportation.
We believe the primary limitations are first, the cost, second, the regulatory environment, third, the user experience and its ability to scale to users beyond the trained astronauts, and fourth, there are real environmental challenges that need to be addressed.
This project was completed by a team of 34 participants from 21 countries, collaborating across time zones around the globe in an online environment. Feels like the future is here already. Our diverse team conducted a literature review of suborbital travel, assessed the current state of the art, and generated recommendations based on individual backgrounds and expertise, as well as the findings of a survey conducted with 217 participants.
In this presentation alone, we had 13 presenters, 5 video editors, 19 content writers, fact-checking by 14 department representatives, 4 graphic designers, 3 musical editors, feedback from the entire team, multiple robots, and of course, our friend from Pluto who can assure you that no cyborgs have been harmed while making this video.
We would like to extend a big thank you to our project sponsor, iSpace, to ISU of presenting us with this challenge and giving us the platform to explore it, to the excellent experts who offered us their wisdom, to our wonderful chairs, Dr. Leanne Chen and Dr. Jan Walter Schroeder, to our amazing TAs, Shuruk, Ankita, Suparba, Nipuni, and Leo, to Alex and Jitu, to all of our coaches and mentors, and of course to the entire TP team. Irina, Essie, Charlotte, Rachel, Vinny, Tiffany, Marcia, Bruno, Nico, Emily, Saswati, Garima, Vivan, Suchesna, Daniel T, Daniel S, Vichal, Victoria, Eva, Luca, Kiara, Mangai, Alexandra, Benoit, Babita, Anna, Kaidi, Scarlett, Sushant, Chidima, Partha, Cameron, and to you, Uli.
Thank you, Michal. We would also like to give a special thanks to you reviewers for taking the time to give us feedback on our research. Uli Shannon, signing off.
Such a storyline, such an execution of the entire project, such a presentation. That was a wonderful, wonderful, tremendous summary of your team project work. Heartfelt congratulations, all the members of the team, all the members of the habitats, Earth, Moon, and Mars. Well done, very well done, Astra Express. So with that, it is now time to get some questions from our experts and audience. And I very well know that all the participants are excited to receive these questions and address them, because as you know, they created a full report, which is 65-page long, which is just kind of summarized in this wonderful episode here. With that, I would like to pass the floor to Kirima and to Susheshna to kick off and moderate the Q&A session. So Kirima and Susheshna, please tell us more about how the Q&A session will work, both for our guests on Zoom call and the guests watching us online over YouTube. So over to you.
Thank you, G2, and thank you everyone for being patiently watching our presentation. So now we will proceed with the Q&A session. So here we will begin with the questions from the jury first, and then we will go with the Strasbourg and Granada platforms, and at the end we will go to the YouTube. So to start with, I would request the jury to raise their hands for the questions to our team. And then we can go by the sequence. So right now, we did receive a question from Mr. Walters, who was not able to be here. So I'm gonna just read the questions, the question that he sent. Till then, the jury will get time to raise their hands, and then further I will take it from there. So the question from Mr. Walter is, previous studies have calculated a ticket price for a suborbital flight, New York, Tokyo at 75,000 USD. What is the team opinion on such a price ticket? So there are two more following questions, but I'm going to go first question at a time. So participants, please raise your hand. Yes, Anna, go ahead, please.
To answer the question of Walter?
Yes.
Yes. So the price of $75,000 is a very appealing one. We would need to know the specific time frame, if you need as of now or if you need some years of operations. What we used in our report is the Foodtron business market study from 2016. Their prediction was that prices would fall from $200,000 to $50,000 in 13 years of operations. This would mean of a 75% decrease in price after around a decade of operations. The price of $75,000 is a 60% drop. So if we're running about the same time frame, this is a very good prediction. As well, if you follow the logic of the Foodtron survey, after another 13 years of operation, meaning 2050, we could expect prices to be $12,500. The route of New York, Tokyo is one of the most appealing routes. So this would likely be one of the most demanded as well. So hence this would provide some flexibility in the price. However, in the early stages of the industry, our target market will still continue to be high time valued individuals with at least $250,000 of annual income. This would mean that this type of demographic will be most likely will favor their time over prices of such $14,000 of a commercial air freight for the same route. Thank you.
Thank you, Anna, for your answer. And the next following question by him was, how do you justify this price with a high standard first class ticket of presently 14,400 USD for the same trajectory? Yes, Anna, go ahead, please.
Thank you. Yes, so as I addressed this, sorry, I answered your question both, but yes, as I said, New York, Tokyo is going to be one of the most demanded routes. And as I said, the demographic will still be continue to be a very specific one. So you're not going to ask the regular person whether they're going to invest $75,000 comparison to $14,000 for the freight price. This would be for bureaucrats, politicians, celebrities, you know, that type of high tier demographic that would much more favor $30,000 for saving 12 hours or so.
Thank you, Anna, for your answer. Over to you, Chidima.
Thank you very much, Sushana. I'd like to take the next question from Michael and Carol. Please go ahead with your question.
Here we go. I was having trouble getting unmuted. It strikes me as interesting that most of the trajectories that have been introduced are essentially equatorial trajectories. Has there been any analysis of whether point-to-point travel could also be useful in polar orbits?
Thank you, Michael and Carol, for that wonderful question. So participants, please raise your hand if you have answers to this question. Please asking if about point-to-point. So please raise your hand if you have answers to this question. Okay, Richard.
Thank you so much for your question, Michael. So yes, if for the optimization of the route length, if the polar orbit turns out to be the most optimum trajectory, we will surely opt that. So it was just a recommendation for equatorial, but yeah, we will also consider polar trajectory if that optimizes the path, because currently we know normal flights also do take the orbital polar paths. So yeah, that will reduce our fuel consumption too.
And so would that require additional radiation precautions?
So to answer this question, our team has studied into some structures and materials, as into to nullify the radiations, but we are still trying to see how we can minimize the overall exposure to the radiation during this flight. And also maybe we will try to lower the altitudes if we feel the time duration is more into higher altitudes, giving more exposure to the radiation background. So, yeah.
Thank you.
Thank you, Rika. I'd like to take one more response from Carl. Please, Mika, go ahead.
Yes, thank you so much. I would like just to add on what my colleague Richard said regarding radiation. So from our findings, the radiation for suborbital flight for one-time flyers are generally redundant. The main concern is for the pilots or the people that will begin to fly more regularly. So this is something that I wanted to point out. We still have some data gaps in this sense, so this is something that we'll definitely explore further. Thank you so much.
Thank you, Mika. Please, does that answer your question, Simon? Michael and Carol.
Yes, that was quite good. Thank you very much.
Thank you very much. Over to you, Sushana.
Thank you, Chidima. Next, we have question from Gary. Hello, Gary. Please go ahead with your question.
Thank you very much. I really enjoyed your presentation, and I thought your report was quite well written also. But I had a question about it's kind of a two-phase question. What is the limit? How many people could you actually take? Because that would bring down the overall cost. And what are the real limitations to taking maybe 30 or 40 people, like in large ship like Blue Origin or SpaceX might have, and you doing the same kind of thing, point to point?
Thank you, Gary, for your question. So participants, please raise your hand regarding the question of how many passengers you can take from point to point, considering the cost. We have Kiara here. Go ahead, Kiara.
Yes, thanks for the question, Mr. Gary Martin. So yes, we analyzed the two kinds of transportation. One is with larger vehicles and with 50 passengers. And this was analyzed by also SIPL, and it's about the space liner. And this would have higher costs, but of course would bring more people and would require a vertical takeoff and two-stage vehicle. On the other side, we would have smaller vehicles that could be easier and more frequent, and would have from 4 to 16 passengers. And this would allow also horizontal takeoff and landing. So analyzing those two, we had a kind of a range of prices for tickets, but there is no huge difference for the final for the passengers. So here we go. Thank you.
Thank you. Thank you very much.
Thank you, Chiara. Gary, I hope we answered your question.
Yes, you did. Thank you. Very nice.
Thank you. All right. So is there any more jury questions now? Please raise your hand. We'll wait for a couple of seconds. If not, we'll go for Strasbourg questions. All right. So next we would welcome questions from Strasbourg platform. So if anyone have questions, please go ahead and you can say the mic over there.
If there's any questions, you can approach the mic and ask your question if you have any questions. All right, I think there's no questions from the part of Strasbourg. Thanks.
All right, thank you. Next we have Grenada platform. So any questions from Grenada, please come ahead.
Hi there. Thank you so much for the presentation. We enjoyed it very much. So we were just, I was just wondering, I would like to hear how they liked the whole process and also being online and creating this wonderful video and also this work. So that would be very lovely if you can share that. Thank you.
Sure. Over to you, Chidima.
I would like to answer that. Please go ahead.
Sorry, did you say my name or someone else?
Yes,
I said Victoria.
Okay. Okay. So for me, it's been a challenge because we have those different time zones, and also we cannot, like discuss things in person. There were very exciting topics we want to talk about, but then we needed to, rush so we could do the videos and edit them. But I take this as a mission, like a space mission. It's been hard. It's been also a very rewarding. And in the end, we know that there's, as everything else in life, there's a beginning and there's an end. And now that we come to an end, we feel a little bit, nostalgic. But yeah, it's a great challenge. And I think that we have, I thought that we would not have this connection because we were not in person, but I see that we have more connection now because we have started the connection through the internet and we can't wait to meet in person. Yeah, that's my understanding and view from all this process.
Thank you, Marcia. Victoria, please go ahead.
Thank you for the question. I think it's a great question. So yeah, it was pretty an amazing experience. We just met by screen. Many of them were still working in parallel and different time zones. So we made the joke that this project just never slept, where there were always someone working on it. I have nothing to add that Marcia already said. I think we created great bonds and friendships for sure. And the only thing is I really want to thank our chairs and Chirup and all the TAs and ISU people who make also the project fun. We had some team building exercise and some really fun activities between the teams. So that also created a lot of fun. So thank you so much for this, and good luck also for all the TP presentation in Granada and Strasbourg. We're looking forward to it.
Thank you, Victoria. Over to you, Sushana.
Thank you. So any more questions, guys? You can come forward from Granada platform, or we will go further to the YouTube.
I get a question, if I may.
Sure, please go ahead.
Hey. So the level was very high. So we are all very impressed by your work. And during your presentation, I can't help but doing a comparison with the Concorde plane, which has been the fastest plane in the world for many, many years for commercial use. And I did a quick calculation on the inflation since the end of the exploitation of the Concorde in 2001, something like that, if I remember well. And in today's dollars, the price for a ticket in the Concorde was something like 15,000 dollars. And the projects of the Concorde began in the 60s. So this was actually 60s and 70s technology. And the Concorde has always been a niche market. And we thought nowadays we would use supersonic flights every day, but now we are using very slow plane compared to the Concorde. Do you believe that the suborbital space flight will stay a niche for the next 30 years, exactly as the Concorde did? Or do you believe that will replace the plane that I use to come to the SSP, which was an Airbus A320, for example? Thank you.
Thank you for your question. Participants, please raise your hand for the answer. The question kind of identifies the importance of suborbital flight, if it's going to be the same for the next 30 years as it is right now, in quite importance. Oh yeah, we have Winnie here. Go ahead, Winnie.
Yes, I didn't quite catch your name, but thank you so much for the question. We specifically added the case of Concorde in our report. I personally find a very interesting case in the economies of scale and how sometimes we think of the futures which might yet to come, and we might be faced with certain realities of markets and how difficult it can be to operate within those markets. I mean, the Concorde certainly faced many, many challenges. One that I personally find very interesting is how difficult it would be to have such commercial flights intercontinental. So say, for example, a flight from Los Angeles to New York, due to, for example, sonic booms and the altitude by which this aircraft would fly. So the Concorde was particularly limited to flights, for example, between the North America and Europe. That's something that, to my understanding, based on the report, would be somewhat circumvented with such suborbital flights, as the altitude would be much higher. And also the development in propulsion technologies, for example, it's intended to minimize the effects of, for example, sonic booms. So obviously, it would be particularly targeted to, as you put it yourself, a very niche market. So people with high wealth, which would be able to afford the high entry ticket prices in the beginning. But as we have a democratization of these flights and they become more widely available, we do expect that they become over time more accessible to more people. It's hard to anticipate whether or not suborbital flights would ever replace commercial liners. I personally don't believe so, but it would certainly be a very interesting option for much longer flights, for example, for distances over 9,000 kilometers, which is something that we also mentioned in the report. So I don't know where you come from. Couldn't quite catch from your accent, but for example, within European states, I would still believe that we would still continue to use airliners. We would consider suborbital flights for slightly longer journeys.
Thank you for your very competent answer, Vinny. Actually, I'm from France. No. So, you guessed it. Yeah, that's why I talk about Concorde. So, and I didn't introduce myself. I apologize. My name is Guillaume. And yeah, it's a very, very good answer. Thank you very much.
Very good question. And now I'll let my colleagues compliment what I said.
Thank you, Vinny. Next we have Uli. Go ahead, Uli.
Hi, thanks, Vinny, for that answer. I just wanted to build on that a little bit because I think something that will be required, we didn't get to address this in the report, but I believe that lots of research shows that to make prices decrease over time, there is a financial instrument that's required. So I think government will play a role, but I also think the private sector capital will also play a role, whether that comes from venture capitalists or private equity. I think that we've seen, even with companies, tech companies today, like Uber, a lot of these venture capitalists, they bootstrap the early days so that these companies can figure out the pricing market. So I am very optimistic that this could happen with Suborbital too, if we come up with a set of investors to invest in this type of technology. Thank you.
Thank you, Uli. Next, we have a jury question from Mr. Michael. Over to you, Chidima.
Yeah, it's maybe a bit of a comment more than even a question. I think we overlook the fact that during the age of exploration, when people were coming from Europe to North America, a number of people, a very large number of people, sold themselves into indenture, which meant for 7 years they had to work for the person who paid their fare. So if you want to have an idea of how expensive it was to make those early trips to North America, just calculate 7 years of labor. That's higher than $75,000 in current dollars. And so it gives you a sense that early elements of different transportation modalities often are very expensive. Hopefully no one will sell themselves into 7 years of labor for a space flight, but it does give you an idea of how expensive those transatlantic trips were in very uncomfortable quarters.
Michael, for that wonderful explanation. If we don't have any more questions from Strasbourg and Granada.
Hi. Just one question from Granada. Hello, I'm Jacqueline. Nice to meet you or see you all again. My question was, in terms of what's next for this team project, what is next for this team? How are you going to continue, this thought process or this experience? What's the next steps for this project?
Thank you for that wonderful question. I would like to call on Esfandea to answer that.
Yes, thank you. Indeed, a very good question. So actually today we discussed how to move forward, because today we had also our last team meeting just before the presentation. And we decided that's a very, very interesting topic, and we invested a lot of time to do research, and we identified that's something that we really like to follow in the future. So we have discussed we will definitely work on a paper to write down the studies, even have more time to do further studies and present them. We had ideas about maybe talking about startups. That was also something that was in the room, but we didn't finalize those ideas. And yeah, I see that Mikal has her hands up. Maybe she can add on that as well. Thank you.
I think that one of the biggest things, especially for me when I participated in this project, was to learn that when we talk about suborbital flight, we don't only talk about the flight itself, but we talk about the entire journey, door to door. So also the pre-flight and the post-flight aspects come into play. Currently, when we look at the pre-flight and post-flight measures that we need to take, the flight duration in itself becomes longer than regular flights. So we have a very large scale of segments that we have to solve or to tackle. And I think there's a lot of opportunity for startups, for products, for developments, for research in all that spectrum. So it's very, very wide. And I think many of us from our different backgrounds are eager to start exploring that. Thank you for your question. It's great.
Awesome. Thank you.
Thank you, Mika. Let's take the last response from Saswati. Please go ahead.
Yeah, I just had a comment to add to Esfandia and Mikhail. So during our research, and we had discussed among our whole team, we want to make this experience as a holistic experience with the envision to personalize space travel. So that was something we had looked into it, and probably that's how we are going to approach this. Digital suborbital passport was an innovative solution that we had come up with, and hopefully will work towards making it a reality in future. Thank you.
Thank you, Saraswati. So I think that's the end of Strasbourg and Granada questions. So we'll move over to the YouTube questions. Over to you, Suchana.
All right, so we have some questions from YouTube. I'm glad to see those. So the first question is, what are the architectures that you have considered, which is from Suzanne Wichtmans. So what are the architectures have you considered while working on this project? And participants, please raise your hands towards the questions. I do see Evangelia. Go ahead.
Many thanks for the question. We actually did an extensive research and identified seven feasible architectures. So what was actually done in this research was they were taking 33 feasible ones and they were optimized towards their operational costs and safety. The cost is strongly linked with the launch mass in our case, because we're talking about a suborbital space liner. And there are different drivers that are crucial to this, such as the weight and the size, the propulsion, the aerodynamics, and the trajectory. Thank you.
Thank you, Evangelia. Next, we have Rachel. She also has an answer for this. Go ahead, Rachel.
Yeah, so I think Eva answered the most main part of it. Also, we also tried to imagine how the future would look like and how can we commercialize this industry. So from that point of view too, we had to look if there is an option for scalability. So for example, if we have considered for now 10 passengers or 20 passengers, in future if there's a demand of, or if there's a necessity, if these structures can be just scaled up or scaled down according to their needs and applications. So that was also, and there were also a few factors that we took into picture considering the future after that. Thank you.
Thank you, Rachel. Over to you, Chidima, for the next question from YouTube.
So this is from Dashon, and the question says, a key concern may be national security as suborbital flights fly above sovereign airspace. How do you think we can overcome this and the potentiality that the flight route is over hostile locations? He wants to know how we can overcome the flight above sovereign airspace and the potentiality that the flight route is over hostile locations. So participants, thank you. I see Vinny. Please go ahead.
Hi, hello again. Thank you for the brilliant question. And that's one of the main legal challenges that we have regarding suborbital flights. Not necessarily 100% number one safety issues, but whether or not we would indeed be overflying the airspace of these countries. There is no legal boundary between air and outer space. So it is still a little bit unclear whether or not we would apply space law or air law. So we don't know if the overflowing states would have to actually provide pre-authorization to be overflown. Because if they are indeed in outer space, or if suborbital flights are conducted or perceived as space activities, which means that the vehicle would be considered a space object and it would be considered to be in outer space. And as we know, Article 2 of the Outer Space Treaty, which is one of the foundational one of the foundations of international space law, dictates that there shall be no national appropriation in outer space, which means that there is no sovereignty in outer space. So in our reporting, one of our recommendations is to treat these suborbital flights at least until a specific international regime is established as space activities, which would in a way circumvent these problems with the overflowing states having to provide free authorizations. So to tangentially address, for example, Michael Simpson's question, a route, for example, from London to Tokyo would be able to overfly, for example, Russia, which is a very challenging issue right now for airliners. But if the object is indeed in outer space, there is no sovereignty in outer space, and we wouldn't have this issue with pre-authorization of the overflowing state. I hope that answers your question. Thank you.
you, Vinny, for that wonderful response. Okay, we'll have one more response from Marcia. Please go ahead.
Yeah, I'd just like to add to what Vinny smartly has already responded. We have also suggested in terms of fostering the suborbital regime for to close those lacuna. So, for example, we have suggested that an ad hoc team should be composed of representatives from the UN Corpus and the International Civil Aviation Organization. So an applicable, specific suborbital legislation could be developed. That is very important in order to ensure that we have safe flights.
Thank you, Marcia.
Just to very quickly complement what was said, just for a complete answer. The landing, as we've been calling the landing state or the receiving state, would actually, the recommendation is for states to have bilateral or multilateral agreements between each other to allow the landing of these vehicles in the landing state or receiving state, or overflowing states, if these activities are indeed considered as space activities, wouldn't be encompassed in that. Now it's a complete answer. Thank you.
Thank you. We do believe that answers your question, Dashawn. So over to you, Sushana.
Hi, so we are going to take 2 more questions before we ask the participants from both the platforms if they have some more questions, and then we are going to wrap up. All right, so the next question from YouTube is, how will you tackle the effects of gravity on human body of different age groups? So how we can tackle gravity effects on health on different groups. Okay, so we do have Garima here. Go ahead, Garima.
So much for your question. Coming back to the answer, first thing is it will be tackled by considering interdepartmental coordination. So the first thing is when you asked about different age group. So as of now, 18 plus is the age group which is allowed to undergo suborbital flights. Second thing is taking into consideration the human performance. So pre-flight training is being given to all the selected participants, and this training ensures that the participants get an exposure what they are going to experience in altered gravity. So I mean there will be an increased gravity during the takeoff and landing, and there will be a period of microgravity. So they will, in trial, will know what they are going to experience. And while undergoing this training, they will also adapt, or their body will also adapt to these situations. And when we are also saying about this, so for example, we are considering the most common health issues, for example, the space motion sickness. So if anyhow this training does not help any of the participants, so pharmacology comes into picture. Second is the engineering and the architectural department. For example, the seats can be adjusted so that the direction from where the gravity will have an adverse effect can be taken care of. So yeah, this is from my side. Thank you so much.
Thank you, Garima. We do have another participant who's a doctor, Saswati. Please go ahead.
Yeah, just to add to what my colleague said, those are the mitigation techniques that we have according to the data that is available now. We do have one of the things we have also recommended in our report is that we do have data gaps because we do not have data from a diverse population, because most of the people who have flown in suborbital or orbital flights or even space travel have been trained astronauts or have received a training much higher than that is expected in the general population. We do not have diverse medical data. So mitigation technologies may evolve in future. Once we have more data, more passengers flying, the pre-assessment is extremely important in the mitigation technologies. Thank you very much. Hope that answers your question.
We do have Rachel. She also wants to contribute. Go ahead, Rachel.
So I think it's almost been answered, but from engineering perspective, we thought of having the trajectories planned in such a way that during the transition, like say for example during takeoff and landing, re-entry, we can have graduates that we experience so that there is no sudden acceleration. So yeah, that is what something our team has thought of while recommending different trajectories. Thank you.
Thank you, Richard. That was an extensive study we did towards the human biology. So thank you, whole group. Over to you, Chidima. The last question from YouTube.
So we've got a question from Niels van der Paas. The question says, what kind of ground infrastructure will be needed at suborbital airports? He wants to know what kind of ground infrastructure will be needed at suborbital airports. So participants, please raise your hand if you'd like to answer this question.
Ground.
I see Richard. Thank you. Richard, please go ahead.
Like normal flights will have all the emergencies standbys, like if there is any emergency landings taking place on the spaceport. Apart from that, we also feel that since we are going to have some rocket fuel in there, we are also going to take some precautionary steps more towards avoiding those explosions, or because rocket fuels are more explosive than normal jet fuel. So yeah, that's one precautionary step that we will be equipping with at our spaceports.
Thank you, Richard. I see Evangelia wants to answer. Please go ahead.
Yes, so the advanced spaceplane infrastructure will involve a ground infrastructure in the form of spaceports, as you mentioned. The aerial, in this case, we will need some special facilities, as Richard mentioned, to conduct medical checkups, to ensure safety, and some others which we will really need to look further into, but they will not differentiate much from the ordinary airport. So we will have a luggage storage, checking, but of course, because here we have to deal with hazardous materials, there is some extra precaution and better planning that needs to be involved. Thank you.
Thank you, Evangelia. So take the last response from Chiara. Please go ahead.
Yes, thanks for the very interesting question. We really studied this, and we came to understand that sometimes it could be possible to transform airports into spaceports, especially those military ones dismissed. But then we also found that we could focus on different spaceport alternatives, such as mainland, offshores, artificial platform islands, and also in the future that could be, for example, no more operative gas or oil platforms. And this could be also, it will depend mostly also from the operational vehicle. So if it's taking off and landing vertically or horizontally. And so these are the future alternatives. Thank you.
Thank you, Chiara, for that wonderful response. Over to you, Sushena.
Thank you, Chiara. Any more questions from the Zoom platform? Please let us know. If no more, then we are going to wrap up the Q&A session now. Thank you, everyone, the juries and the participants on Zoom, and also the public from YouTube. We really appreciate your questions. This has been a great session, and we appreciate your patience for sitting for a presentation and hearing so keenly and gaining knowledge. Thank you so much. Over to you, G2.
Fantastic. Thank you. Such an exciting topic indeed to work on, and such a great job you have done to put it into research and presentation in such a comprehensive way. So, and also I would like to thank you very much, Kadima and Sushesna, for moderating the Q&A session, and everybody definitely responded to the questions. Just for everyone watching online, as I mentioned before, the project report and the executive summary of this project at Astra Express will be uploaded to the ISU library in a few weeks. So I do encourage everyone in a few weeks to go and download this report and download this executive summary and read it through. As I said, this time in less than an hour, it's not possible to even address everything that has been thought of. So I do encourage everyone to go and have a comprehensive read through to this document. And as Svandir was mentioning, this is not the end. This is indeed the beginning of this team project as well. So there will be more articles and more presentations are definitely on its way. With that, ladies and gentlemen, this indeed brings us to the end of the final academic deliverable and the event of the online SSP21 session, which was the team project presentations. So I would like to once again express my sincere congratulations to all our participants and their supportive chairs and teaching associates for this amazing work, which just happened in 6 weeks. It's just hard to imagine, even for myself. I well know how hard you have worked, all of you, across the time zones for the last 6 weeks to make this possible. I hope that each of you is proud of yourselves, which you truly deserve. And I also want to send a thank to all the families behind the screens, because yes, we did see 34 people in front of the screen working in this project, but without the support behind you, your families, your moms, dads, kids, friends, without their support in such a compact time, nothing would be possible. So once again, all the families, all the back-end crew who supported this main crew here, a big shout out from all of us here at International Space Station. Wow, I'm already in the future, you see, International Space University, to all of you. So I also once again want to acknowledge and thank our team project sponsor as well, the Beijing Interstellar Glory Space Technology Corporation, and all the experts who joined us and challenged our participants with the questions. With that, as the director of SSP21, I hereby declare the success of our team project, and it is now time to, well, come back home from our celestial habitats. We will now sign off for some hours and be right back at the SSP21 online session closing ceremony at 6 p.m. UTC. So for our audience following us online on YouTube or Zoom, please follow the address isunet.edu/live at 6 p.m. UTC. Once again, when the time comes, which will take you to a different YouTube link where you can watch the closing ceremony of this very special online SSP21. With that, I would like to thank you very much for joining us for these presentations, and see you in a couple of hours. Take care and stay safe.